When cattle graze in a pasture, the process appears straightforward. The animal consumes grass, breaks it down in its stomach, and extracts energy. However, biology reveals a different sequence. When cattle swallow their feed, they do not actually digest it first. Cattle obtain very little of their energy directly from the grain or hay they consume. Instead, that feed travels into the rumen, a massive natural fermentation tank where the true breakdown of food occurs. Inside this tank lives a microscopic workforce. Billions of tiny living organisms reside here, performing the actual labor of digestion. Feeding a 1,000-pound animal is a biological illusion. The diet is actually fueling a hidden microscopic ecosystem. Inside the rumen, the microbial city operates with incredible density and a highly specific division of labor. This workforce is divided into three main classes: bacteria, protozoa, and fungi. Specific microbes break down tough, fibrous plant material, dismantling rigid structures the animal's enzymes cannot touch. The remaining groups tackle different targets, dismantling starches and proteins. This coordinated labor is the only reason raw, indigestible plant matter can be converted into something useful for the animal. The rumen acts as an active biological manufacturing plant, rather than a simple demolition site. As the microbes consume and digest the feed, they continuously excrete a chemical byproduct. These outputs are volatile fatty acids, or VFAs, specifically acetate, propionate, and butyrate. These excreted acids, the waste products of the microbes, provide the cow with the vast majority of its usable energy. Without this exact conversion process, an animal eating a diet of high-quality grain would still face starvation. This biochemical handoff dictates the entire strategy of modern agricultural management and nutrition. Feed mill managers and farmers occupy the role of micro-ecosystem managers, prioritizing the internal environment of the rumen. Modern feed rations are mathematically designed to satisfy the specific requirements of the rumen microbes. Keeping this workforce alive requires a perfectly balanced ration, adequate physical fiber, and constant access to clean water. Stability is maintained through consistent feeding times, which ensures a steady internal environment for the microbes. Sudden diet changes shock the system. As variability spikes, the microbial population suffers an immediate, dramatic crash. A collapsed microbial population immediately halts VFA production. This leads to a drop in feed efficiency and triggers severe digestive distress for the animal. Bovine biology dictates that feeding the cow directly is a physical impossibility. The focus remains entirely on the microscopic workforce, as healthy microbes are the only mechanism capable of building healthy cattle.